Hello, everyone.
I
Uh, Today's class is about active and passive buzzers. Kaushik, can you explain what you have, searched so far about active and passive buzzers?
okay. So what I've searched so far is that active buzzers, they have a piezo disc and a time chip in it, where the time chip it creates electric like pulses that vibrates the piezo disc at 2,500 beats per second. So it's just one sound the whole time. It can't be changed. It's gonna stay as one sound. So you can see it in like car alarms or whenever you have a microwave and it's like done, the alarm goes off. And for passive discs, you can control them because they don't have a time chip, they have a piezo disc. So what it does is that it takes those electric currents and it based on like how so you need a computer chip to like control the electric currents which then vibrate the piezo disc so you can control the electric currents, you can make it go how fast you want, how slow you want, meaning that you can literally make music with it. And yeah.
Yeah, exactly. And you know, uh, I want to explain about this piezo, whatever you told, piezo, right?
Yes.
So
Yes.
piezo refers to force.
Okay.
Now you understand.
Yes.
Okay, let me tell you in detail. So we have three states of matter. Can you tell me what are they?
Uh, liquid, solid, and gas.
Okay. So in the gas, do we have molecules, right? Which are
Yes.
spaced,
Very spread out.
yeah, very spread out. So can you tell me what happens when you talk?
The sound scatters into the gas and like it bounces off the particle or molecules. I'm
Yeah,
pretty
yeah. So suppose let us assume the molecules are like this. Okay, here I have drawn them very, in a structured way, but in real there will be randomly placed.
I can't
But
see
when you,
anything.
oh, okay, okay, sorry. Let me share my screen. I forgot to share. Is it visible now?
Yes.
Yeah. So let's take the molecules are like randomly present in a room. Whenever you speak, let us say when you speak, there will be some force acting. You push some molecules. So here there will be like molecules will be together here. And when you go after a distance, maybe they are like little more spread out because your force is not that much on them. But over time, when this molecules hits the second one, and then the second one hits the third one, so it forms like a chain reaction, right? So it
Yes.
goes and hits it, and then it's come back again. So you can see, at if you take any particular time instant, then you know molecules will be like together in some places, and they're spread out at other places, and again they are together in some places.
Hmm.
So these are known as compressions, and these are known as rare fractions. You can note this down. So whenever you speak, unknowingly you're producing many compressions and rare fractions in the air.
So compressions and what?
Compressions and rare fractions.
When we speak,
Yeah.
we produce
Compressions and rare fractions in the air.
compressions and what?
Rare
Rare.
fractions. Rare
So
fractions.
RARE and then fractions.
Yeah, exactly. FRACTIONS.
Okay.
Now, what happens is when you place, uh, let us say, when you place a cloth,
Hmm.
a sheet of cloth, and when you speak and when you touch the cloth, you can feel vibrations, right?
Hello.
Huh?
Yes.
Yeah, those vibrations are nothing but these due to these compressions and rate fractions in the air.
Oh, hello.
So if there is no air, then will the compressions and rate fractions pass?
Um, no.
Okay. Okay. This tell me this one. Let us take solid, liquid, and gas. Can you tell me now in which medium does the sound travels fastest?
Gas.
Gas. Uh, what about solid and liquid?
Solid doesn't even travel through while liquid very little passes through.
See, okay. If we come back again to the concept of sound, so whenever we speak, we produce these compressions and rate fractions in the air.
Yes.
Suppose if the material is tightly packed, then these vibrations can move faster, right?
Oh, yeah. But sound can't travel through a solid.
Yeah, but the vibrations can.
I guess, yeah.
Yes or no?
Yes.
So now considering this, now can you tell me in which case the sound travels faster?
Solid,
And then,
liquid,
and then, yes,
gas.
yes. I just want you to, look about what is the speed of sound in these three mediums
Okay.
after the class. And let me know in the next class.
Okay, gotcha.
So these compressions and rate fractions, when they hit the diaphragm, they uh, when they hit the diaphragm, suppose if I connect some electrical component,
Hmm?
let me erase this one. So I'm having a diaphragm, and then
Yes.
I'll connect some circuit. Okay, whenever
Okay.
this diaphragm moves, I'll get the readings. Let us say
Yes.
if the diaphragm moves, some voltage will change in this circuit, or some current will change in the circuit, and then I will record those currents and voltages. So this is how we convert the whatever compressions and refractions present in the air to electrical signals.
Okay.
So whenever you speak, there is this diaphragm in the mic which vibrates, and these vibrations are converted into readings.
Mhm.
So that's how my microphones and all other things work. And if you look at how fast these readings are done, uh, I just
I
want you
can't
to look
hear
up.
you. Your voice is breaking.
Is it good now?
Yeah,
Is it
now
okay?
it's yeah.
Okay. I just want you to look at what is the sampling frequency of microphones.
Right now.
Yeah, right now.
Uh, is the what is the sampling frequency of the micro sampling rate?
Yeah, sampling rate.
Um, the number 44.1. Wait, what?
Forty
It's telling me
forty
that the num
four point one kHz.
yes, but that's for
So,
CD quality. If you're asking for video and broadcast standard, then it's
okay, fine, fine.
48
I just want
kHz.
only for audio. Now let us see what this so-called 44.1 is. It's pretty interesting. Okay, let me. So you have 1 second, right? 0 to 1.
Yeah.
I just want you to note this formula down. Frequency equal to 1 by time period. And the unit of frequency is hertz. And the unit of time is seconds.
I'm sorry, what? So the unit of frequency is hertz.
Yeah, it is
So Hz.
HERTZ.
So H and Z for short.
Yeah,
And then the time period is
seconds.
seconds. So yeah, got it.
Can you tell me what is the frequency if time period is 1 second?
If time one.
What? Okay. So if I divide 1 second, okay, if I take this part as 0.1 second, 0 to 0.1 second as one time period, can you tell me what's the frequency?
0.1 second is what time period that would be like
Yeah, just
something.
write down. Just keep F and T here and put T equal to 1, then F equal to 1. And now T is 0.1.
Yeah,
Then
I
what's
know how to
frequency?
do it. I'm just trying to do the calculations in my head. It would be 10.
Yeah, 10. So how
How
did you
did
get
that
10? You
take me
just,
so long?
okay. So you just divide 1 second in 10 parts. Okay.
Oh,
Then
I see
each,
now. Yes, yes. So the frequency is kind of like the speed, and then the time period is how much time you have.
exactly. And okay, let us come to that 44 later on, but I just want you to understand this deeply. Suppose if the time period, let us suppose if you again divide this 0.1 in 10 parts, can you tell me how much one part will be?
Point something.
Oh,
Point
okay. We
zero
forgot to
one. Point
fill it in the
zero one.
table.
Point zero one. Wait, no. Point
It's
zero
10
one.
here. So yeah, again, if you divide this 0.10 in 10 parts, it will become
Point zero.
0.01.
Yes.
Okay. Can you tell me what's the frequency of that?
Is it one? I mean point one.
Yeah, what's the frequency of 0.01 if the time period is this one?
Point
If the time period is 0.01, what's the frequency?
100.
Okay, it's 100. Well,
Yeah.
yeah. So to get 100, if the frequency is 100, you just imagine first you have to cut 1 second in 10 parts, and the each 10 oh each part in again 10 parts. Then that one part is nothing but this 0.01.
Yes. Correct. Affirmative.
Okay. Now frequency is 44.1 kilohertz. Kilo refers to 10 power 3.
Okay.
Hmm?
Yeah. Yeah.
Okay. Okay. Then yeah, I thought you I thought you will say the answer.
Oh, you want me to say the time
If the
period?
frequency is 44.1 into 10 power 3 hertz, then what is the time period?
Um, 10 power 3. So 44.1 is the frequency.
Yeah,
Oh, okay. So it would be 44 point.
44.1 into 10 power 3 is the frequency. It's around 44100 hertz.
Okay, so 44100 hertz is equal to 1 over x.
Yeah. How much is the time period then?
4410.
It's 0.00002267
How do you get
seconds.
that?
And you
How
just
do
do
you
1
get that?
by 44100.
Then 441. Um,
Yeah, 44.1 kilohertz is nothing but 44.1 into 10 power 3, which is nothing but 44. This part, right? This
Yeah.
decimal here. So it's by 10. And you cancel. It becomes 10 power 2. And that is 10 power 2, and this is 441. Any doubt in this?
No.
No. Can you see the time period?
Possibly.
Yeah, how much small it is. It's if we milli, and then it's like 22.6 microseconds.
Oh my God. What's microseconds?
Okay. You know what is millisecond?
I understand. I understand.
You
I
divide
know
one
what.
millisecond into 100 parts again. So each tiny part is 1 microsecond.
How fast would that go?
That's what you just imagine. So at this much fast rate, the microphone captures the differences, the readings.
Meaning.
For every 22.6 microsecond, the microphone, whenever you speak, whenever I'm speaking, the microphone is getting the values of the
Oh.
compressions and rarefactions in the air for every 22.6 microseconds.
Mhm.
Can you imagine how much fast it is?
Slower than me.
You divide 1 millisecond in 100 parts, and each part is 1 microsecond. You just imagine how much speed it is.
Yeah. Still slower than me.
So, are you understanding how much faster the mic is?
Than me, no.
So, what did you understand from this then?
I understand from this then. Just how fast a microsecond is.
So, hey, stop playing.
Wait,
Stop playing, I said. So,
so what
did
I
you write down
understand.
this? Did you write
How
down?
to find the frequency or the time period.
Yeah, if you stop playing and listen to the class, then you will understand. So, that's what I told you, right?
Happen.
The formula frequency, frequency equal to 1 by time period.
Yeah.
Yeah, write it down. If you just simply listen,
I wrote it down already.
then put a table f and t, and if time period is 1, what's the frequency? And if time
One.
period is 0.1, what's frequency? If time period is 0.01, what's the frequency? And
Okay.
if frequency is 44.1 kilohertz, then what's the time period? It's around 22.6 microseconds.
Huh.
Write these values down. So in the last video I saw, you purposefully skipped the frequency part.
What do you mean? No,
Yeah,
I
you thought I would
remembered
not,
this from last class. I'm like, why are you teaching me this right now?
because we are dealing with the buzzer, right? So we need to
Yeah.
understand what's the frequency and how it's, you know, working and all. And similarly, yeah, I just I don't know how I forgot this. So
No, I
in the ear,
remember this.
canal, we have this drum. So even the drum vibrates, and these
I know that.
vibrations are converted into electrical signals, and these electrical signals are sent to the brain, and then we are able to interpret the sound.
Okay.
So that's how biology is, and we are trying to use the biology and make it in electronics. Okay, so coming to the topic, basically inside every buzzer we'll be having
Quick
this
question. Quick
PCO.
question. Yes.
Okay,
So what if you send commands to the brain? Would you be able to control a person?
as of now, no, but in future maybe yes. Okay,
Yeah.
in the brain, if you take a specific every part in our body is mapped to specific parts in the brain. Suppose if
So
you
what if
open
I
this,
control the brain?
no, like you can't control it totally, but I'm just giving you an example. If you open up the skull and if you put some electric current in this corresponding
Shifts.
part, which is mapped to the arm, let us suppose, then by touching this part, you can move this arm of the person.
Yeah, that's what I was thinking. I'm like, what if I was able to put a microchip on a person's brain? Wouldn't that just make them a cyborg?
Yeah, exactly. But yeah, it's far away.
Good to know. Good to know.
So yeah,
Okay.
vibrations create pressure waves, and these pressure waves reach our ears as sound. In case of electronics, they reach the piezo. Whatever the
PZO.
piezo you have told, piezo material or this thing present in this
Mhm.
buzzer. So basically, we have an oscillator. What this oscillator does is it takes the DC input. Like what are these 5 volts you give? It takes that 5 volts and it converts it into
Vibrations, pulses.
pulses exactly like compressions and refractions. You can think of it in rough sense. And then you
Uh,
have this control logic, transistors and all, which control these pulses.
but
And
that
then
would be for a passive and active buzzer.
this is for the active buzzer. For the active buzzer, you have
I
the
thought you
oscillator
couldn't
inbuilt.
control the active buzzer.
Sorry?
I thought the active buzzer only made one sound.
Yeah, exactly. That is able to make one sound because it has an inbuilt oscillator. And
Okay.
that oscillator has only specific frequency. And you
Mhm.
cannot change the frequency of that oscillator.
Then why did you say we could control the pulses?
Did I say?
Yeah.
Sorry, it was my mistake then.
Okay. Okay.
So in the active buzzer, you cannot control the frequency of the pulses.
Okay.
So that's the reason why you get only one sound in the active buzzer.
But then the
So
passive buzzer doesn't have an oscillator.
exactly, passive buzzer doesn't have an oscillator. So whatever the frequency you give as input, it plays it as output.
Oh. So you could play music with it. So like play a whole song if you wanted to.
Yeah, exactly. We'll do it at the end of the class. But before that, I want you to know a little bit of concept of what is going on inside.
Okay.
So did you write down that oscillator converts DC into square wave, and this
Yes.
square wave is given to the diaphragm. So that's the reason it only vibrates in only one frequency. It's able to produce only one frequency.
Oscillator converts.
So you should explain why this is only one kind of sound.
Converts DC.
I mean, why the active buzzer produces only one kind of sound?
Why? Because you can't control it.
Because you cannot change the frequency of the oscillator inside that active buzzer.
Yes.
And what's an oscillator? At this point, you just remember oscillator converts DC into square waves or
Buzz.
pulses.
Uh-huh. Yeah.
Okay, so what's an oscillator and what's this all about active buzzer?
Just all of that. Okay, so an oscillator converts DC into square wave, and basically an active buzzer creates one sound, and so it only has one frequency that you cannot change.
Okay, so the sound is produced by the square pulses, which are produced by
The DC,
the
which is pretty
oscillator.
early oscillator.
Okay, suppose if we can control the oscillator's frequency somehow, then can we produce many frequencies then?
Yes,
Yeah,
that's how the passive works.
yeah, but the passive buzzer doesn't have an oscillator inside.
Yeah.
Okay, so yeah, I have the code for the active buzzer. I just want to No, it's the same like a digital, right? Or else uh, you can check it by putting 5 volts and 0 volts in the two pins. See, uh, so you take the breadboard, you put the buzzer in such a way that you have one pin in
Wait,
one
this is for
column and another
active
pin in,
buzzer, right?
yeah, active buzzer.
For a passive buzzer, are we gonna use analog, right?
Yeah, kind of analog, right? Yes. Yeah, why are you playing? Do
I'm
it.
just
Connect in the
concentrating.
breadboard.
Okay.
Take the buzzer, put it in the breadboard such that these two pins are in the two
Um,
different columns,
how do I tell the
and
difference between an active and a passive buzzer?
you just connect in the circuit and check whether if it is a passive buzzer, because you are giving DC as input, it will probably not sound. But if you keep the active buzzer as it is having an oscillator inside, so it can produce a sound.
So I just gotta experiment to see which one's the passive buzzer and which one's the active buzzer.
Yeah, you
Okay.
just use the 5 volts and 0 volts pin in the Arduino. And even for the active and passive buzzers, you have this positive sign on top of it. So you
Okay.
need to connect the 5 volts at the positive one and the other end at ground, which is nothing but 0 volts.
Mm-hmm.
Yeah, do it then. What are you looking at?
I am opening my Arduino.
Yeah, why do you even want to open the Arduino when you can test it with the 5 volts and ground? You just need the power source, right?
Now fine. Okay. Um,
First, we'll check whether the component is working or not, and then we can go to the Arduino and
uh,
then we can manipulate it by writing. The rest
how
is the
how do I
code.
wire it? How do I wire it?
So that's the
Like,
reason you need to listen to the class.
mhm.
So you just put the buzzer in the breadboard such that the two pins are in two different columns.
Okay.
And at the positive side, you take that terminal and put it in the 5 volts. And the other terminal, you put it in the ground. I mean, you take another wire and you connect it to the Arduino. And now you put the other end of that wire in the breadboard.
What?
Connect two wires to the Arduino 5 and 0. And now you take two male to male wires. Or
I think I found the active buzzer.
oh, why am I not hearing it?
That hurt my ears.
Okay, fine. Try to put it 3.3 volts and let us see whether it changes or not. Maybe the sound level may change.
That was louder.
Okay, fine, fine. Now you check for the other buzzer whether it's working or not.
Huh? Oh, నువ్వు చేసినావా అది గుడ్ మ్యాన్. Now you want me to write the code?
Code is fine. Like it's similar to how you write for the LED, whether the blinking LED
So you
or
want me to
anything.
write the code now?
Yeah, not right now, but I just want you to try with the other buzzer as well, whether the passive will make it or not.
Well, it probably won't be okay.
Why?
Why? Because, oh, maybe it will.
Huh? No,
And
because there's
that's
no oscillator, right? Which
one way to find out.
yeah, okay, fine done. So in order for the diaphragm to vibrate, you need to give it pulses.
Yes.
As the active buzzer is having the oscillator, it can produce the pulses by using the only DC input whichever you are giving. But in case of passive buzzer, as it has no oscillator, you need to give the pulses itself.
It only like snaps once and then it just stays frozen.
Yeah, exactly. That's what it's supposed to do. See, whenever, okay, okay, just listen
I
to
know
this.
that's
Listen
what
to
it's
this first.
supposed to do because I remember reading that while I was studying it.
Okay, when you did not connect the passive buzzer, initially it was low. Yes or no? It was low.
Yes.
But whenever when you gave the 5 volts, it suddenly become hey, it suddenly become high,
Yes, because it has the power source.
and then it was high subsequently.
Mm-hmm.
So you had only one beep. I mean one change. Maybe when you remove it, maybe in that case again you can hear it
Okay.
when you disconnect.
Mm-hmm.
Yes or no?
So yes.
So that's what. In order to have the sound, you need to have a pulse. I mean, you need to
Yes.
have a change from low to high. So
Mm-hmm.
that's what this clearly explains that one. So
Okay.
whenever you did not connect at first time, it went from 0 to 5. And when you removed it, it went from 5 to 0. In between, it was 5. There was no change in between of 5 to 0. That's the reason you did not hear anything. God, what are you doing?
Testing.
Stop. Okay, that's
It's
fine. That's
my
fine.
ears are hurting.
Yeah, okay, don't listen to it too much. You just take a pen or pencil, just put some mark on it so you can differentiate between active and passive.
No, there's actually a way to differentiate. The passive buzzer has like this line thing underneath
Okay,
while the active buzzer doesn't. So yeah.
okay. So
Okay.
can you
So
explain me why the passive buzzer, when when you inserted it, it beep, and when you removed it, it beep, and in between it did not beep.
I because the power source only makes it like it sends only one pulse through and that just makes it like snap or something and then it just freezes because you need an active pulse for the passive buzzer to keep on beating.
Yeah. In order to get the sound, you need to have these compressions, rate fractions, compressions, fractions, which are like
Yes.
lows, highs, lows, highs, lows, highs.
Hmm.
Okay.
While it only went high and then stayed low the whole time.
Yeah. So at
Okay, so
starting it went from low to high, and at the end
code.
when you removed it, it came from high to low.
Yes, the code time.
Code time, but see, you don't need to write code every time.
Hmm. I know, just save
You,
it.
you just go through the code. You just read it. Here we can understand. If you see the screen, it's just int, which you already know.
It's just the same as an LED, basically.
Yeah, exactly. You just give delay, make it high, make it low, and then you can play with it using for
It's
loops and all.
literally the same as an LED.
Yeah. So yeah, let's skip this.
Uh,
uh, Let us see at some of the points. As we cannot change the frequency of the pulses, the active buzzer can only play one fixed tone. It cannot play any music. And depending on the oscillator, the frequency is dependent. You cannot change the frequency of the oscillator.
yes.
So here comes the passive buzzer. So these are a diaphragm is present, a magnet, and a coil is present. So by using this coil and magnet, we'll be able to move this diaphragm.
Hmm.
Okay?
Yes.
Yeah. And yeah, this is the main thing in the passive buzzer. So here, the as the passive buzzer has no oscillator, here the Arduino itself becomes the oscillator.
Okay. Okay. Mhm.
It sends the high, low, high, low, high, low in different frequencies. Hence, you can use it to change the frequencies of the buzzer. And
Uh-huh.
I just want you to know, can you sound a low frequency? Can you sound like a low frequency?
Can a sound have a low frequency?
I am asking you to sound like a low frequency.
Is that it?
Okay, bass like boom, boom, boom.
Oh. Wait, no, that's high.
Not not that sound.
Oh.
Yeah, exactly. Those
Oh.
things are passes. Those things are low frequencies. Now, can
Okay.
it sound like a high frequency? Can it sound? Can you make a sound of high frequency?
Is that lit?
Like I did not hear it actually.
Can you hear me?
Now, maybe this thing is filtering out. Okay, let me explain you what a high frequency will sound like. Uh, if there is some sudden ghost or something, you know how ladies, girls shout? Huh?
No.
Did you hear
Oh,
it?
I see what's happening. So like this thing, it keeps on it doesn't it like so it like makes no sound if I make a loud sound. Like,
Yeah, exactly. Like it's acting like a filter. It's only passing some
yes.
frequencies. So that's the reason I think even you did not hear whatever high frequency sound I had made. I had made.
Maybe there's a way to change it.
Yeah, that's fine.
People
That's fine. Don't worry. Let's do
audio
it with let's
settings.
do it by using the buzzer. Let's do it by using the buzzer.
Wait, no. Wait, I got it. I got it. Did you hear me?
Uh, no, actually. Yeah, you can just imagine how girls shout when they, when something happens. Yeah, yeah, this sound. How did you
You
do
heard
it?
it?
Yeah, how did you do it? Yeah, I think it's buzzer. Yeah, that's
Yeah.
fine.
I
But
wrote
just
the
imagine how
code.
girls shout when they see some ghost or something in the
Wait,
movies or
wait.
in some web series. So it kind of sounds, that's high frequency.
Okay.
So okay, coming back to the concept, I just want you to go through this line and make a note of it. It's very important.
This is how many times the diagram vibrates every second. So you want me to write frequency tells us how many times the diagram vibrates.
Yeah, you just first understand it, and then you can write on your own.
Okay, so the frequency just shows us how many times it vibrates every
So
second.
if frequency is 1,000, the diaphragm vibrates 1,000 times every second.
Mm-hmm.
If the frequency is 44,000, it means the diaphragm will vibrate 44,000 times per second.
Mm-hmm.
Can you imagine 44,000 times per second? It's insane.
Is it though? Is it
Yeah, it is. So did you make a note of it?
run a mile in point zero 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 zero
Yeah,
zero zero zero
that's impossible.
next.
That's impossible. Let's come back to the topic. So higher is the frequency, higher is the pitch.
Mhm.
Yeah, make a note of it as well.
So just how many times
In
the
order to, yeah, did you write these 2 points?
no
Yeah, right.
diaphragm diaphragm
Yeah, diaphragm vibrates.
vibrates per second, and then higher frequency equals higher pitch. I-
Yeah.
and done.
Okay, that. Okay, coming to the passive buzzer, here
Tone.
see you need to know these two functions. So this is how you write to the passive buzzer.
Okay.
So here frequency, you'll tell about the frequency in the tone. So basically, tone takes two values. One is a pin, one is a frequency. It's like the minimum requirement. Yeah, you should write these two, three things also. These are the functions in order to interact with the passive person.
So we need tone, frequency, and pin. Do you want me
Just
to read
if you
that piece of code?
no, first write it in your book. Yesterday when I said you, out of those 6, 7, 8, 5, 9 pin buzzer, I mean PWM signals, there
Yeah.
were these two pins which corresponds to 960
Nine
hertz
nine
and
eighty.
the other
80, I mean
980, and the other three pins they corresponds to I think
four
490 hertz, right?
490, yeah.
Yes or no?
Yes. Correct.
S-
Affirmative.
Okay. So in the 490 hertz, I think the time period is around 2 milliseconds. Fine. And let's say it approximately.
Okay. Yeah.
So by using the analog, right, we have manipulated this pulse width, whatever the pulse on and off duration. Yes or no?
Yes. 50
Even
around.
in the 6 and this one, let us say if you take a 50% duty cycle, can you tell me what will be the on time in this case?
0.1 millisecond.
1 millisecond. In case of these other two cases, uh, the time period is around 1 second. Can you tell me what is the time period of? I mean, time period is one. Can you tell me what's the time for 50 duty cycle? On time of 50 duty cycle, 50% duty cycle.
Point 0.5.
Yeah, 0.5. So in these two cases, we are not able to change the time period, but we are able to change the duty cycle.
Yes.
Yes or no?
Correct.
Correct. Fine. So now what this frequency does is it keeps the duty cycle at 50% for each time, but it changes the time period.
Okay.
Now, this is the main thing. This is where you should understand. Now, did you understand the difference between the analog right and the tone?
Yes.
So in the
Analog.
tone, we are able to change that time period itself, but
Yes.
we cannot change the duty cycle. It's fixed to 50%.
While the analog, right, you're just kind of like controlling on and off.
Yeah.
So the duty cycle.
If you try to use analog right and keep the X value according to the 50% duty cycle, then you can listen to only one frequency. If you
Oh,
use the pins corresponding to 490 hertz, you can listen only that one. If you use the pins corresponds to 980 hertz, then you can listen to only that one. But you cannot change the frequency itself. But by using the tone, you can change the frequency. So it can change the time period.
okay.
So yeah, write these three functions down in the notebook.
Tone and oh, you want
Yeah,
me to
tone.
write the
Yeah,
three
write it in the notebook.
codes? Tone.
Uh, Normally, two pin and frequency is enough. But if you specify the duration also, then the duration is in milliseconds. So it will automatically produce that corresponding frequency for that particular duration and then it will be turned off.
Okay. So I let's say pin 8, comma 480 hertz, comma 5 seconds. Would it work like that?
Yeah, hey, it's not 5 seconds. You need to give 500, yeah, 500 in order to play it for 5 seconds because it's a
Oh,
milliseconds, right?
uh-huh. And then to stop
Sorry,
it,
it's
just
5,000, 5,000, five
like,
thousand in order to
uh,
play for five
and
seconds.
then just to stop it, it's just delay.
Yeah, no, if you delay it, it continues to sound.
Oh, why?
because you did not turn it off. In order to turn it
But
off, you
if
need
I
to
turned it off, like tone, pin, and
no.
then low, and then delay off,
You need, if you want to turn it off, you need to use this no tone
oh,
and then pin number.
and then delay.
Yeah, and then delay. That's fine. Like if you want to do it, then tone, pin frequency, and then delay of
Yes.
how much time you want, and then you can write no tone.
Okay. Hmm.
Anyhow, you can directly put this delay in another comma, right? So it's much more easy.
Yes.
Okay, fine. So now is the coding part. I want you to use the passive buzzer and then connect it to this one.
Pin number 8.
Yeah,
Got it.
as you are using, yeah, just try with the different pins. Take 8.
Yeah, I took it. Tone 8. So I only write the code in void loop and nothing else.
Yeah.
Should I name pin 8 as an output?
Yeah, I'm sure.
Do I not
Yeah,
need
it's
to?
just similar to an LED. Just think it as similar to an LED. Instead of
Okay,
digital write on analog, right?
name
You are
it.
just using tone.
So I name it as an output.
Yeah.
Okay. There's a no tone pin. 8. I'm gonna put pin mode parentheses 8 comma put and then boom. Okay.
Yeah, I think I heard it. Is it working?
Yes, but isn't it supposed to go off?
Yeah, it went right after 2 seconds or so.
No, it's just going on.
Check your code. Like, have you given no tone and the pin correctly after the delay?
Yes. Yes, I have. Wait, can I check my code once?
Yeah, check it. That's all.
Yeah, it's good. I mean, I put tone 8 for 500 and then delayed it for 2 seconds and then no tone 8. Let's just keep on.
Oh, you have not put the delay after no tone.
Oh, oh my god.
Now you
So,
get it right.
so it's just going super fast off.
Yeah, exactly. This is the point.
Yes.
Oh, it's really cool when we discuss like this and code, right?
Yes.
Yeah, excellent.
There we go. Now it's working.
So did you write down these 3 function names
Yes.
in the
Tone,
notebook?
frequency, function.
Okay. So what frequency did you use right now?
At 2000.
2000. Okay. Try with 500.
Okay. And higher the frequency, higher the pitch, right?
Yeah, yeah, that's what I told. You just keep some high frequency like 10,000 or so, and then you try to listen to it, how it will be. Then you'll try to, relate with whatever I told you earlier, like when girls shout, that's what. Yeah, yeah, naturally girls have, girls can speak higher than the boys in terms of frequency.
I know.
Yeah,
It's like,
yeah, exactly. Yeah, now I heard you. So that's what. So now you understood the difference between low and high frequencies, right?
yes.
So did you hear the 10,000?
Yes.
Okay. Now let's. We have already come across this for loop, but now I want you to code it right in the class itself.
What did you
Can you read the code and tell me what the code does?
For int f equals 2000, f is less than or equal to 2000, f plus equals 20. So it starts at 0, or no, it starts at 200, and then it just keeps on increasing by 20 until it is greater than 20. Then it goes into no tone.
Yeah, yeah, it's greater than 2000.
It's lesser than 2000 right now.
Yeah, but over a time, if it goes greater than 2000, then the condition no longer satisfies, then it comes out of the loop. Can you see the curly bracket here? It comes out of the loop and then, it does no tone.
Yeah. Hmm?
Yeah, I want you to code this. And here, instead of 2000, you keep 5000.
Okay, that's gonna take a while.
And after no tone, you add delay. Again, it will be like the previous case, where again you will complain to me like it's not turning off.
Well, it wasn't. So like
Yeah, that's fine, no problem.
four
We learn by making mistakes.
and f equals 200, and then semicolon. F is lesser than or equal to 2000, semicolon. F plus 20, and then F plus equals 20. More curly brackets? Okay.
Yeah, these curly brackets, once you enter the loop, you need to place these curly brackets.
Why? Curly bracket.
So whatever we're writing for, it's a loop.
Yes.
It goes on continuing until the condition uh, is not is satisfied. It goes on till the condition is satisfied, and it comes out of the loop when the condition is not satisfied.
Mhm. 20, and then boom. No, no space. And then no tone 8. What do I have to type in students here? Pitch increasing.
Sorry?
Do I need to type students here? Pitch increasing? Because does that really change anything? No, right?
I'm extremely sorry. Can you come again?
So like at the very end, it says students here pitch increasing.
Yeah, it's yeah, it should increase, right? As the frequency is increasing.
Yeah, but do I need to write that in my code?
Okay, write it and check.
I don't think I need it. All right. And then, why is this not opening up? And then, 2. It's kind of like a car or a police siren. I don't know. Hello?
Yeah.
Yeah, it's working.
So what did you observe?
It's like it's like and it just keeps on repeating from there.
Okay, okay. I just want you to. Do you remember yesterday we saw another for loop being written, which started like from uh, uh, 2000, and then it was like f minus equal to
That was
20.
the for what was it? I forgot.
For the
LED.
PWM, right? Yeah,
LED.
LED. Yeah,
Mhm.
can you turn off the that thing now and try to code for it?
Okay, so now I need a
Just
code.
add for loop. This time you remove no tone because you need to hear it continuously, right?
Yes. But for this thing, it didn't stop.
So you just add another for loop, but this time you
Uh,
keep f
Five
as
thousand.
2000. No, like
Five.
whatever the limit you have put in the upper part, you just put it.
Okay,
But
you put 5,000, so I'm just gonna put 5,000.
yeah, fine. You put 5000 and then you put a stop condition. So you want it to go till f greater than or equal to 0, right?
Yeah, no,
Once it
I know.
reaches negative values, then
F
it should not go into the loop.
should
So this should
be
be your condition.
greater than or equal to 0, semicolon F minus equals to minus it by 20.
Yeah, 20, because you need to make it uniform in the both loops in order to understand the increment and decrement.
Mm-hmm. And then tone and everything else is the same.
Yeah. And then after the second for loop, you add no tone and you put significant delay.
Semicolon delay. And then I add no tune after the second thing and then semicolon delay. Okay.
Yeah. Don't add no tone after the first for loop.
I know. Semicolon and then delay by how much?
And the delay of 20 remains same inside the two for loops. It's like giving, it's like once you reach 200 frequency and the next 220 frequency, there should be some gap, right? So that
Yes.
gap is nothing but 20 milliseconds, 0.02
Okay.
seconds.
I
So
know.
yeah, you can run it and you can try to listen to it, how it is.
Okay.
Hello? How is it? Is it like a police or
It's kind of
ambulance?
confusing. It's confusing to see whether it's going high or low. Let me make the delay after the known tone even longer and see if I see it.
Yeah. By experimenting like that, you can understand where the for loop is,
Yeah.
stopping and then continuing. That's a good way to do it.
You notice that the person in front of you gets 5 apples and
Interesting. Yeah, I can see the difference now.
Okay. Just
It's
save this thing
like
and
at the
put it
end.
as.
It's like at the end. It isn't in between of them.
Hmm, okay. Just
What the?
save this all codes. Save this all codes.
Okay.
Now I want you to. So basically, when these 8 notes, sa re ga ma pa da ni sa.
Yes. Uh,
In Western, it's like do re mi fa sol la ti. Do re mi fa sol la si. So
the-
each note corresponds. You just turn it off. You just turn it off.
You want me to play music like that?
Yeah, we'll do in the meanwhile, but first understand the notes.
Yeah, I understand
So
the notes. I know already. We
each
learned them.
note corresponds to a particular frequency. Which is
Yes.
fine so far?
Mm-hmm.
Okay, okay. So I want you to make a new file and then write these particular notes.
Mm-hmm.
Yeah, after writing two lines, you can just drag it and then copy paste it, and you can just change the
And
frequency.
I'm adding more things. Pin mode, buzzer. Oh,
Yeah,
space.
whatever
Buzzer.
I'm explaining each time, you just make a new file.
Yeah, I'm making a new file each time.
And after the class, you just save it accordingly. Save it neatly in the folder.
Okay, this is gonna
This
take a
thing that
while.
jumps out at me.
So tone, and then boom, and then 8,264. Oh
Uh,
no, 8 comma
yeah,
264
like
350.
if you have defined int some buzz equal to 8, then you can directly write the buzz here.
Okay, int pin frequency and duration.
Yeah,
Okay.
pin frequency and
Wait,
duration.
why is 260 staying the same? Okay. 264, 264 comma 250, and then semicolon, boom, delay 300. I'm just gonna keep on copy and pasting that. Tone, Command C, return Command V, and then it stays the same. That's great. And then Command C, and then boom, Command V. And this time it changes to 297, 500, 297, 500, and then Command C, Command V, and then it changes to 264, 500, and this one's 550, 264, 500, and this is 550. Command C, we is it if it's 352 and then 550. And then 550, yeah. And then finally it goes to currency. Do you want me to add a delay at the end?
Yeah, add it.
Okay, give me a sec.
I'm very curious to listen what it will sound like because I don't know.
Thousand,
ChatGPT gave me this thing as a body notes, but I did not experiment with it.
550. Okay, done. Give me a sec. What?
Yeah, did you make it run?
Uh, one sec.
Yeah, what happened? What are you doing?
Nothing.
Yeah, tell me.
Upload. I see what happened. Now upload.
Yeah, is it good?
No, it's not done yet. Wait.
How is it?
Is it? Wait. What's it supposed to sing?
How is it sounding?
Yeah, I can hear it. It's different. Yeah, I can kind of hear like a happy birthday to you.
Yeah, exactly. Yeah, that's what it should sound like actually. If you see the heading here, I think you missed this thing. See here.
Wait, can you hear it?
Yeah, I can. Did you see here? I'm highlighting
Yes.
here.
Uh-huh. Okay, how did I miss that?
You can just unplug it and let's come back to the class. So uh, this is what. Hello?
Hello?
Yeah, I highlighted it.
Okay.
Okay. That's fine. That's fine. You just remove it for now. Let's come back to the class. It's time for
Let me
me to
get my
sleep now.
charger.
I'll just find out.
Yeah, I need a charger. 1 second, let me get a charger. Yep. Now I'm ready.
Okay. So, a quick
Yeah.
question for you. You just answer me whether yes or no in the each case. Oh my God, turn it off. Yeah, you have whole day to play with it.
Okay.
So the first one is oscillator. You answer me whether you have an oscillator in active and passive.
Oscillator inactive.
So what about digital, right?
Sure, right. Inactive.
Okay, good. What about tone?
Passive.
What about music?
Passive.
Okay, I just want you to know, write this table in your book as well.
Okay. So feature. Happy birthday to you.
And don't worry, I'll give you homework.
Right. The tone.
You just write the features down and answer it yourself.
Okay. X. 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 Okay, so oscillator for passive, digital right for passive, tone for active, and music for active.
Okay.
Wait, actually, I wrote it with a pen.
Yeah, correct it, correct it.
How?
Change the heading.
I'm joking.
That's right. Hey, oh my God. Okay, fine. Coming to the summary, can you tell me what we have discussed so far?
We have discussed active buzzers contains an oscillator. Passive buzzers require Arduino to generate a square wave. Tone changes frequency to produce different notes, and different frequencies create music. And then different frequencies create music.
Can I have a quick question? What's the
Yeah.
frequency?
Frequency is the speed of sound in the sense.
Okay. If I
In
have
the
frequency as 10, what does that mean? Frequency is 10 hertz.
It's 10, it means the diaphragm vibrates at 10 hertz per second.
Yeah, that's what I asked you. What's 10 hertz? So that the diaphragm
10 hertz
oscillates.
is the frequency.
Yeah, the diaphragm oscillates 10 times about its mean position in 1 second.
Yeah, correct. Affirmative.
So yeah, your homework is yeah, same to make a video. Hello?
Yeah,
Yeah, turn it off.
turn what off?
Yeah, the sound it
You
was
thought
ringing your
that WhatsApp call was from this thing? This computer is connected to my dad's phone, so
okay, fine. You just put click on wrong button or something. So the homework for you is to make a video, explain about active and then passive buzzers, and then
okay.
explain what is the difference between them and how you can control the passive buzzer. And also, I want you to get the tones for simple rhymes like happy birthday. You complete it. You take the help of AI and complete the whole song of happy birthday. And then
Mhm.
you also try the song of you can try for Jingle Bell.
Jingle bell walking.
Yeah, I want you to show these
Uh-huh.
two songs in the video at the
Okay,
end of the video.
okay.
Fine? Is it good?
Uh,
Everything okay?
yes.
So any more questions?
No. Do you have any questions?
No, even I don't have any questions. Fine. So did you enjoy today's class?
Yes.
Yeah, even I enjoyed teaching.
Mm-hmm.
So yeah, okay then that is it. Bye bye. Have a good day. And yeah,
Bye.
looking forward for your video. Make
Okay.
it as well.
Okay. Mhm. All right. Bye.
Okay then.
Have a good
Wait,
day.
wait, wait, wait. Last sec. Can you tell me what's the homework given to you?
To make a video explaining passive and active buzzers and how we can control passive buzzers and play Jingle Bells and Happy Birthday, the whole song at the end of the video.
Yeah, and also explain the difference between them.
Yes.
You know the table which I made you to write.
Yes.
Okay then. Okay, that
Okay.
is it then. Bye bye. Have a nice day.
You too have a good night.
Thank you.
Okay. Bye.